Hello, please. My name is Dr. Newton. Welcome to my YouTube channel, Dr. Newton the Tutor. Please make sure to subscribe, like, and share. This channel is your go-to destination for informative and also engaging educational content. So please make sure to subscribe. Okay. So today we are going to talk about circular motion. Circular motion. So now, what is circular motion? So when we say circular motion, it's the movement of a body or a particle in a circular path. So simple and concise. So when we say circular motion, it's when an object moves in a circular path. So whenever an object moves in a circular path, that means it is undergoing circular motion. So now, typical example is merry-go-round. I think we've all seen merry-go-round before. So the motion of merry-go-round is circular motion, and also satellite in its orbit. You understand? So when the satellite, when satellites orbit around Earth, it is undergoing circular motion. So also when a string tied at one end and wheeled around, that one too is circular motion. So now let's look at practical example of circular motion. So this one over here is practical example of circular motion. You can see that this is a merry-go-round. You can see that it is spinning. So right now it is undergoing circular motion. As it spins, it undergoes what? Circular motion. It's quite interesting though, looking at the motion of this merry-go-round over here. So we have uniform circular motion. So when we say uniform circular motion, it occurs when anything moves along a circular path in a consistent way. So this means the object will start from a point and move in a circular path and return to that particular point, that starting point. So that's uniform circular motion. Okay, so the object will move in a consistent way or in a definite other. Okay, so now we are moving to angular displacement. So now what is angular displacement? So when we say angular displacement, it is the angle covered by a body in a circular path. It's the angle covered by a body in a circular path. So we can see theta over here. So theta is a symbol, the symbol of angular displacement. Theta is a symbol of angular displacement. And also the unit of angular displacement is radian. The unit of angular displacement is radian. And also we have theta is the symbol of, I've already said that. So theta is a symbol of angular displacement. And we are saying it is the angle covered by a body in a circular path. Okay. So now let's establish this one over here. So we have we are going to establish certain formula for angular displacement. So the revision of formula. So now let's say we have our theta. So you can see the theta over here. That's why we are saying angular displacement, or theta, is the angle covered by a body in a circular path. Theta is the same as angular displacement. It's a symbol used to represent angular displacement. Understand? So you can see our theta over here representing the angle covered by the body in a circular path. So okay, let's say we have Q over here. So Q is our first point, and we have this line over here which is serving as a string. You understand? So at the end of the string, we have tied a certain object. So that object is the P. That object is what? The P. So if the string is to undergo circular motion, it will cover a certain distance. It will cover what? A certain distance. That means you are going to wheel the string, more like wheel the object. So the object will undergo circular motion, or the object will move in a circle. You understand? So let's say this one to be our face. So the object will move from here. So there is the initial position. If it is to undergo circular motion, it will move from its initial position to its final position over here. So this one is the initial position and this one is the final position. So it will cover a certain distance. It will cover a certain distance. So this is the distance over here. So it will move in a circle. You understand? So this is the distance, more like the arc. The arc over here. So if you want to, we can also say the circumference. You understand? Because it will move in a circle, and at the end it will create a circle. And the tip of that circle, or the distance around that circle, it's x over here, and you all know that the distance around the circle is circumference. So this is our x over here representing the distance, you understand? And we know that since this one is tied to a first point, so this is the first point. If you are to heal P, or if P undergoes circular motion, you understand? At the end, this one over here will serve as the center. This one over here will serve as the center of the motion. You understand? And we know that at the end of the motion, you are going to get a circle. And also we have our line over here. So this one is R. The R is actually representing the radius, because you know that any line from the center of a circle to its circumference is the radius. You understand? So this line over here, the strength. So we know that the strength is from the center of the circle, and also its ends are the circumference of the circle. You understand? This one over here is also the radius. So this is the strength. So the R is the radius. So let's derive the formula. Okay, so angular displacement over here. So we have our object the same. This one is the same diagram. So this is our R, radius x, our first point over here, the object, the initial position of the object tied to the strength, and the final position of the object tied to the strength. So if the object is to undergo circular motion, or if we are to swing the object, it will cover a certain distance, and that is x. So x over here, you understand? So by drawing our diagram again, so this diagram over here is the same as this, but just that here we have changed some certain things. Understand? We have changed, but the position is the same. So looking at x over here, you see that this one over here is opposite to the x. The same thing applies to this one. You have our r over here. So you can see that this one over here is right angle triangle. So now we are deriving formula for angular displacement. So looking at this one over here, we can see that for us to derive the formula, since this one is right angle triangle, for us to derive the formula, we are going to use the trigonometry ratios. So for the trigonometry ratio, I think you're already familiar with it. We have sine theta, cos theta, and tan theta. So sine theta, cos theta, and tan theta. So here we have to look out for the trigonometry ratios that can help us derive our formula. And I think the best trigonometry ratio to do the magic is sine theta. So this is our sine theta, because sine theta, for here we only have two parameters, which is the r and the x. You understand? Our parameters r and the x. So here for r and the x, you can see that the x is representing the opposites. So the opposite side of the diagram, you can see that x is opposite to theta. S is opposite to theta. That's why we are saying x is the opposite, and r is the hypotenuse. And bear in mind, always hypotenuse is opposite to 90 degrees. So here it's forming 90 degrees, and you can see that it is opposite to, or the longest side of the right angle triangle is the hypotenuse. So here the best trigonometry ratio that will help us is sine theta, because sine theta is equal to opposite over hypotenuse. So here we have our sine theta, which is equal to opposite, and we know that opposite is the x, and we have our r, which is the hypotenuse. You understand? So opposite on hypotenuse. So sine theta is equal to opposite. So now we are deriving our formula. Okay, so for small angles, sine theta is equal to theta. So when we say small angles are angles that are less than 15 degrees or equal to 15 degrees. So we consider them to be equal to the actual angle. So looking at, let's say we have sine 12 is the same as 12 degrees. Sine 12 degrees is the same as 12 degrees, because they are considered as small angles. You understand? They are considered as small angles. So sine theta is equal to theta. Okay, so now looking at this one over here, we can see that the theta, since sine theta is equal to theta, we can rewrite our formula in this form. So theta is equal to SR, because sine theta is the same as theta. You understand? So theta is equal to SR. And S is equal to what? So this one is we are just making S the subject. And bear in mind, S is the distance covered by the object in undergoing circular motion. Understand? We have the radius over here, which is the R. So the X is serving as the distance. And also we have our r over here, which is the radius. So we can just make s the subject, the same formula, but make it. So the actual formula for angular displacement is theta, which is representing angular displacement over here, is equal to x over r. X over r. Okay, so now let's solve some examples on angular displacement. Alright, so we have examples of angular displacement. So now, what is the angular displacement in radians? So as I said earlier, angular displacement is measured in radian. Okay, so what is the angular displacement in radian when an object moves through 8 meter in a circular path of radius 7.5 meters? Okay, so our solution. So now the parameter is given. We have our s, which is the distance covered by the body moving in a circular path, and we have our r, which is the radius of the body moving in a circular path. So to find the angular displacement, we have to state our formula. I think we have derived the formula earlier. So we have theta is equal to x, which is representing the distance, and r, which is representing the radius. So by substituting in the values into the formula, we have theta is equal to 8 over 7.5. So at the end, we are going to get 1.06 radian. 1.06 radian. That will be our answer for this question. Okay, so that's how to find angular displacement. You just write your formulas, you substitute in the values, then you get a final answer. So now our next topic will be radian. Our next topic will be radian, which is the SI unit of angular displacement. Try these questions over here and send your answers to me through my WhatsApp channel. So I actually have WhatsApp channel where students connect, where we discuss, where we share questions. You understand? So it's a platform for students to share questions and also get to know each other. We connect schools. So please send your answer with your name attached to it to my WhatsApp channel, to my WhatsApp channel. So I'll put the link in the description box. So click on the link to join the channel and send your answer to me through the channel. So there is the try questions over here. So make sure you try these questions over here and send your answers to me through my WhatsApp channel. Thank you very much for watching this video. See you next time, and please don't forget to subscribe and like this video. Thank you. Gracias.